Okay, let me get this into present mode. Okay. So as I mentioned in my introductory video, the online course is new for me as well. So I'll be definitely hitting you up on feedback and seeing how things are going and that type of thing throughout. One of the things that's most difficult for me is that I don't have a pulse for what's going on. And when we take notes, in a lecture format or that type of thing, I can always tell if my students need more time. Obviously, I can see that, or a student can obviously raise their hand and say, can you repeat that or something like that? And we lose that here. So when you see something like you're seeing right now, a lesson that is going to look like this, we're going to be doing it in an outline form. I'll talk more about that in a couple of minutes here, and you're going to have to pause me a lot. So if I'm going too fast for you, you just pause me and you get the information that way. And again, we'll check in and see how that's going. So I also will do wait time after I talk or as I talk, and hopefully that'll help. But pausing me will be the most efficient way, I think. So you need a notebook for this class. And I mentioned that earlier, so hopefully you have it. On the first page of your notebook, I want you to draw your hand or outline your hand. Don't worry about how poorly, or you can see my fingers don't look like that. My pinky finger especially, it doesn't look like that. But so go ahead and outline your hand. As you're doing that, I'll be talking a little bit about why I use outlines. I think outlines are really effective because they create an organizational pattern for me and you. They tell us what things go together, what subheadings fall under other types of headings, and that information. So I'll be using an outline format. I'll be going really, really slow with it in this first lesson just to make sure you're following it. Okay. The other thing I want to talk about before we get too far into the hand thing here is our first unit. Our first unit is about research. Everything in psychology is grounded in research. This isn't just some old guy who comes up with an idea and people think, oh, that sounds right. That might be right. The information that we're going to talk about this semester is grounded in research, replicated many times over. And I think it's really, really important as a learner, a lifelong learner, not just in this course, but when you hear information that, people say is true, I want you to be able to critically think about that information, ask yourself where that information came from, how it was discovered. So we'll be talking about that all semester. If I give you an interesting piece of information, we'll talk about how we know that. And whether it should be questioned and that type of thing. So hopefully you have your hand written down. Now, 3 of these go together, the 3 in the middle. So observation, case study, and survey go together. They're types of descriptive research, we call them. You don't have to worry a lot about the notes. We'll be taking these piece by piece, okay, right now. But this is all you need. The 2 that are different than the other 3 are correlation and experimental. So let's talk a little bit about those and why I put them where I put them. Try to use this as a mnemonic device. That's why I figured 5 research, 5 fingers kind of goes together. Could have drawn our toes, but might have been kind of repulsive for some people. So when we look at these, we see the 5 types of research. I added a little bit to them as to why I put them where I did. So the 3 that go together, again, are survey, case study, and observation, the 3 in the middle. You've all taken surveys before. You'll be taking them again. In fact, at the end of the semester, you'll be taking a survey about this course, right? You've done it for every course at WCTC and hopefully other courses as well that you've taken. And to me, when I hear of a survey, I think of someone pointing at me saying, you are going to answer these questions. So that's what I wrote on the outside of the index finger. You are answering my questions, okay? And think about someone pointing at you. The middle finger is pretty easy. It's not because case studies are bad or anything. It's because they take a long time. And unless maybe you're kind of weird, your hand is kind of weird, but I think most people, the middle finger is the longest. And a case study is the longest type of research. So that's why I put it there. And then thirdly, we have what's called naturalistic observation. I just wrote observation, and then I wrote naturally place rings because this is the ring finger, and you can have rings on other fingers, obviously. But at least in my mind, when I think of a ring, I think of putting it on the ring finger. So, and that's a natural thing to do. And when we have naturalistic observation, that's exactly what we're doing is we're observing organisms in their natural environment. You don't have to write that down. We'll get to that, but that's just why I put it there. The pinky, I think about correlations are relationships. And I think when you make a pinky swear with someone, you're making a relationship with them based on the topic that you're swearing on. So that's why I put it there. Relationship pinky swear is what I wrote there. And the thumbs are opposable. They're what separate us from lower forms of life. They allow us to grasp things. That it's pretty difficult to say which finger is the most or least important, but the thumb is probably the one that allows us the most flexibility and allows us to do the most things. So on that one, I wrote it's the most often used, and it also shows cause effect. Can't really see the word effect there, but that's what it's there. That's what's there. So because the experimental method is the most important of these 5, I put it on the thumb, and that's the one we're going to start with. So if you don't have these things written down, you can pause this and write them down. I'm going forward and talking about experimental research. Okay, now, like I said, we're going to do an outline. So that's a Roman numeral 1, experimental research with an equal sign. I'll get to what that means in a second. We're going to be looking at pages 18 to 22 and 28 to 30 for this. And whenever you see an equal sign in my notes, it means that we're defining that, okay? So I know that some teachers just write the definition on the presentation or give them to you, but again, research shows that when we write things down, we tend to recall and learn them better and recall them better. So we're going to define experimental research as when a researcher attempts to show cause effect. So you're writing this next to the equal sign. When a researcher attempts to show cause effect by manipulating variables in a laboratory setting. Okay. When a researcher attempts to show cause effect by manipulating variables in a laboratory setting. We're going to underline some key words here. Cause effect is really, really important for an experimental research design. Manipulating variables is really important, and laboratory. So we're going to underline cause effect, manipulating variables, the laboratory setting. And again, if you're not getting these, just pause me and slow me down. Okay. Now, what we're going to do next is we're going to have a capital A that goes underneath the Roman numeral, and it's also indented. So indent a little bit, maybe, I don't know, an inch or so, maybe, and write setting up your research. Now you'll notice there's no equal sign there, which means we're not writing anything other than setting up your research. And this next page, you're not going to write anything. I just have it there so you can see what your notes are going to look like today, at least most of them. So you'll see that we indented the A. We're going to indent number 1, number 2. We're going to indent, and this is how your notes will look. So you don't have to write, I guess you don't have to write anything yet. We'll go to the next page. Okay. So here we go. Number 1 is create a hypothesis. So I'm going to see if I can move myself here. Yeah. See if that works better. Okay. And so create a hypothesis has an equal sign. So that means we're defining it. Creating a hypothesis for our purposes, I'm sure you've heard of hypotheses before, is making a prediction using an if-then statement. Okay, making a prediction using an if-then statement. Underline the words if-then. Now, hypotheses don't have to have if-then statements, but I have found that when students use if and then, it not only helps them to make an actual prediction, but it also helps them with the variables. That's why we do it this way. So once we have our hypothesis, we're making a prediction. For example, does playing violent video games cause people to be more aggressive? If I want to make a prediction about that, I can use an if-then statement and say, if a child plays violent video games, then they will be more aggressive. Okay, so that would be an example of a hypothesis. I could also say then they wouldn't be more aggressive, but that the point is that I'm making a prediction using those words. Next, we're going to set our variables. So We don't have an equal sign next to that, so we're not defining anything there, but we are going to define the independent variable. So after you write the small a independent variables, or independent variable, this is the variable that the researcher measures. Okay, so you are writing that. It's the variable the researcher measures. Underline the word measures. Okay. Manipulates. Sorry, is the independent variable is the variable the researcher manipulates. So change measures to manipulates. I could redo this whole video, but I'm not. So when we talk about operationally defined, let's go back to that hypothesis first. If a child plays violent video games, then they will be more aggressive. I'm going to be manipulating whether or not they play video games, okay? So that's what I'm manipulating. So when we operationally define the independent variable, we talk about how, okay? Operationally defining the independent variable, we talk about how. And what I mean by that is, how is the researcher manipulating the variable? Okay, so if the independent variable is playing violent video games, how am I going to manipulate that as a researcher? Well, what I would probably do is have two different groups, one group playing violent video games and another group playing non-violent video games, if there is such a thing. And then later on, I would compare the results. So the operational definition of my independent variable of violent video games is half are playing violent video games and half are not, okay? So that is how I would go about operationally defining that, okay? The dependent variable is the variable the researcher measures, okay? So we have that as our B right there, dependent variable equals the variable the researcher measures. And the operational definition is the same thing. It's the how, okay? So your subscript I, operationally defining the dependent variable how are we measuring the dependent variable? This is a good one. This is the example that we're using, aggression. How do you measure aggression? You know, that's complicated. So you have to define that. You have to tell people, I'm going to measure aggression by, and maybe you're going to put them in a situation where you're playing a game, soccer or dodgeball, and you're going to measure how aggressive they are as they play the game. Or maybe you're going to give them a survey and you're going to say, give them situations where someone cuts you off while you're driving. You know, do you A, ignore them, B, beep your horn, you know, that type of thing. But I have to say how I'm measuring it. And that's the operational definition. So the dependent variable is simply measuring aggression. The operational definition is I'm going to do it by using a survey and then a little bit more specifics, but that's the idea. All right. And then finally, you're going to set your groups. Sometimes groups are called conditions. They're used interchangeably. So we have to know both. All right. And there's two conditions that we need to be concerned with. Okay. The first condition is called the experimental condition or group. So obviously I'm down here. And the experimental condition or group receives the independent variable. Okay, they receive the independent variable. The control group does not get the independent variable or gets a placebo. We'll talk about placebos later. Okay, so the control group does not get the independent variable or they get a placebo. So let's go back. If a child plays a violent video game, then they will be more aggressive. The independent variable is playing the violent video game. The dependent variable is their aggression. The operational definition of the independent variable is going to be that half of them are going to play a violent video game, half of them are playing a non-violent video game. The operational definition of the dependent variable, I guess we'll use a survey. Our experimental group is going to play violent video games. Our control group is going to play non-violent video games. So that is kind of the setup, okay? Now, one more thing before we move on to the next slide, and that is that if you struggle with either variables or hypotheses, just a little hint, it's almost always if independent variable, then dependent variable. So there's three ways you can use this. If you struggle with hypotheses, go right to the variables and then go back and write your hypothesis with the independent variable after the if and the dependent variable after the then. If you struggle with variables, write your hypothesis and draw your variables from your hypothesis. If you're pretty good with both, then that's a good way of checking your work, right, to make sure that it lines up. Okay, so what we're going to do next, my slides aren't running right now, this way, is we're going to practice, okay? So we're going to give you two different situations, okay? So the first situation or first practice is we want to know if a student who tests in a room different than the room they learn in will do worse on a test, okay? So if we're in a face-to-face setting, we're going to be in the same classroom all year or all semester, and what if their first test or some test, we move to a different room? Would that affect your test performance, okay? Or if you're doing it online, if all your online learning is done in the same room, should you test in that room or should you test somewhere else? And our second practice is, would a child who is disguised be more likely to steal, okay? So those are our two questions, okay? So let's work on the first one right now, all right? We're going to take that context, it's called the context-dependent memory, learning in the same environment, or testing in the same environment we learned in. If a person tests in an environment different than their own, then they will perform worse on the test. Could be a hypothesis, it's our prediction. Independent variable, the room the person tests in or the participant tests in. Dependent variable, their test score, right? I'm manipulating the room that they're going to test in. I'm measuring their test score, okay? Operational definition of the independent variable. Remember, that's the room, right? So half of you will test in the same room you learn in, and the other half will test in a different room. So that's how I'm operationally defining the rooms, okay? Then my operational definition of the dependent variable is I'm going to give a 20-question multiple choice test and compare the averages. So that's how I'm operationally defining the test scores, okay? Finally, the experimental condition, they test in a different room. The control condition tests in the same room, okay? So that's basically what we have, all right? You don't have to write anything right now. I hope you're not trying to write all this down. I probably should have mentioned that. But here's what I do want you to write down, okay? I want you to pause me, and I want you to copy the screen on the right where it says disguised and steal. And I want you to see if you can get the you can get the hypothesis, the variables, the operational definition, and the conditions, okay? The operational definitions could be kind of confusing because you have to be creative about how to go about doing this. And I'll tell you how I would do that, or how we could do that, but just take a shot at it. So pause me and answer those questions. Okay, so here's what I wrote, okay? Here's my hypothesis. If children wear disguises, then they will be more likely to steal. Okay, remember, hypothesis and variables, right? If independent, then dependent. So the independent variable is whether they are disguised or not. That's what I'm manipulating, right? The dependent variable is whether they steal or not, okay? Now that's not enough because what do you mean by disguised? How are you disguising them? What kind of situation are you going to put them in to steal? Well, I'm going to use Halloween, okay? So my operational definition is going to be Halloween. I'm going to have half of the children who are wearing costumes have masks as part of their costumes, and the other half are not going to have masks. So that is going to be how I'm manipulating being disguised, okay? What about measuring stealing? Well, here's what I might do, and I'm going to tell you more than I have written here, okay? But I would have, one of the houses would have a bowl in front of it, and there would be a sign that says, please take only one. And I would have a camera that would be watching that bowl. And we would count how many kids who have masks steal candy and how many kids who have masks don't. And that's what we can compare, okay? Are there problems with this? Oh yeah, and we'll get to those later. But for now, let's just go with it, okay? My experimental condition wears masks and my control condition does not, okay? So if you were able to get everything but maybe the operational definitions, that's awesome, okay? Because operational definition pieces, take some out of the box creative thinking. And we're not going to worry too much about that right now. But I do want you to have the hypothesis, variables, and conditions nailed down, okay? Okay, so let's go to our next topic, which is basically going to sum up the first part here, and that is assuring representative participants. Okay, so we're going back to writing our notes again, okay? And we have a number 4, which is under number 3, right? The conditions. And before we talk about random samples and random assignments and all that, one of the biggest mistakes people make in all research, not just experiments, but all research, is they don't have a population that they are measuring as truly representative of a sample, okay? Once in a while, I'll see MSN or Fox News try to do surveys, and those are not legitimate surveys because the people who are watching already are leaning a political way, right? So the surveys that they're going to get are going to be totally bogus surveys. So whenever you look at results of studies, especially if there is a motivation for them, always look at the source, and a lot of times that will automatically tell you whether you should use it or not. For example, how many people support saving polar bears? If that was done by PETA, that's not a legitimate survey. How many people think that gun ownership should be legal? If that was done by the NRA, that's not going to be a good study. Okay, so it's just automatic. So one of the things you want to do is look at those. So let's talk about these. A random sample. Okay, a random sample is when every member of a population has an equal chance of being in the study. Okay, a random sample is when every person in the population has an equal chance of being in a study. Okay. So random sampling is used for all types of research, experiments, surveys, whatever, okay? The population, pretty much what it sounds like, okay? The population is the group of people available for the survey, or I'm sorry, for the research. Okay, the group of people available for the research. To be a random sample, we need a representative sample. Or to go from a random sample, rather, we need a representative sample. And a representative sample, pretty much what it sounds like, a representative sample truly represents the population studied. Okay. So if the University of Wisconsin wants to do a study on their students, they want it to be a representative sample, they need to have every single student have an equal chance of being in that study. Okay, and the best way to do that is a computer random generator. Okay, where obviously all the names are in a computer and the computer randomly pulls out however many they want. So if they want 100 of the however many students they have, it's going to automatically pull out 100. Okay. Now, random sample can be used in any type of study. So maybe go back to your definition of random sample and maybe in parentheses write any research. Because random assignment's different, okay, a little bit different. Random assignment is, and we'll write this first maybe in parentheses, only in experiments. So random assignment is not used in surveys, case studies, correlations, or naturalistic observation, okay? Only in experiments. And random assignment is, once we have our sample, the people in the study have to have an equal chance of either being in the experimental group or the control group, okay? Once we have our sample, the participants need to have an equal chance of either being in the experimental group or the control group. So let's go back to our video game aggression study. And let's say that we're going to do it on fourth graders. Okay. So if Lincoln Elementary School, if we are going to do a random sample of fourth graders at Lincoln Elementary School, and let's say it's a big school, let's say they have 200 fourth graders, we're going to put them in a computer random generator. We're going to pull out 40 of those 200. That's our random sample. The 200 are the population. Okay, because all 200 of them had an equal chance, it's truly a representative sample. Once we have the 40, then what we're going to do is take that 40 and put them in another computer random generator or flip a coin or something like that and decide which group is going to go into, or which person is going to go into which group. Okay, so we're going to have 20 in the experimental, 20 in the control, And how they ended up there was purely at random. Okay. So let me give you an example of how we could screw up random assignment. What if the what if the principal at the school was doing the study and they took the first 40 fourth graders that walked into the school? That's not a representative sample, right? Because the first 40 could be different than the last 40, right? In terms of their background, maybe the parents are getting rid of them, so they're dropping them off because they can't deal with them. Or maybe they're students who love school and they can't wait to get there. Well, that's already, we're beginning to see some biases in the type of person that their participants are, right? So we can't do it that way. So using a computer random generator for both the sample and the assignment is always kind of the safe